Okay, let's go to exercise 1A now. First question. The position of x power 53 in the expansion of summation from m equals 0 to 100 of 100 cm x minus 3 power 100 minus m. Okay, 2 power m. Okay, it's just of course. So this thing is just like the expansion of x minus 3 plus 2 to the power of 100 basically, right? So it goes from 0 to 100. That's why this thing exactly. So just x minus 1 to the power of 100. So you just want the quotient of x power 53 in this expansion. You know what, I'm going to write this 1 minus x to the power of, or let's not do it. So you got 53, right? So let me 100 c 53, and then you will have x power, so 100 minus 53, or in fact, yeah, whatever, just x power 53, and then negative 1 power whatever the other thing is, which is 47, I guess. Yeah, because that will be 100, so that makes sense. So we negative in that case, so negative 100 c53 and then x power 53. So negative 100 c53 is the coefficient. So b, first b. Okay, cool. Next, second is the value of square root 5 plus 1 to the power of 5 minus square root 2, square root 5 minus 1 to the power of 5. Yeah, whatever, just expand this out, right? So just to the power of 5. Just use Pascal's triangle first of all, like 1 2 1 1 3 3 1 1 4 6 4 1, and then finally just got 1 5 10 10 5 1. So you notice that it's a plus 1 and minus 1 over here, so and it's subtraction, so only the odd r values will survive, right? Because even r values get cancelled, so you only have to deal with the second term, the fourth term, and the sixth term, right? Okay, so you will have like r is equal to 1, that will survive, so 2 times of basically 2 times of, so when you put r is equal to 1, just get 5 times square root 5 power, let's see, 5 minus 1 is 4, so square root 5 power 4 is 5 power 2, that times 1 power 1 yeah, then you got plus 10 times 5 power. So now you will have r is equal to, so you got 1 2 3 3, that means the remaining part is just 2, so square root 5 power 2, right? It's gonna be 5, just 5. Then you got finally this guy, so you got square root 5 power 0, and then just 1 basically. So it's just this thing plus 1. Yes, that should make sense. So this will be like 10 times 5, so it's like 250. Yeah, plus 100, and then you got plus 2, I guess. So this will be 352, which will be B. All right, let's go to the next question. So third, the question of what 3rth term and question of r plus second, okay, this term in the expansion of 1 plus x power 2 and r equal, then where r is okay, whatever. So yeah, an expansion of this guy, huh? So the 3rth term, that's like r is equal to 3r minus 1. I know this looks weird. Yeah, you just get the idea, right? 2nc 3r minus 1, that coefficient is equal to 2nc, well, r plus 1. That's what they're saying. So let's do this thing. It's got 2n factorial, that's gonna be there anyway. So yeah, I mean the denominators will be equal. That's just all you have to say. So 3r minus 1 factorial, and that times of, what do you actually want to find out though? Oh, so what is r going to be? So n minus of this guy. Ooh, that is not good. Okay. So 3r should be, oh wait a second. Just do 3 times of this everywhere. So 3r upon, so 3n upon 2. That won't be there because so the last term can only be like n, I mean 2n plus 1. That's the number of terms. So there will be 2n plus 1 terms at max. Okay, in that case 3n upon 2 can actually be there. Well, okay, n can also be there. So 3 upon 2 times n plus 1, that still can be there. And fine, so all of these are actually feasible. Now I just have to solve this. Right, so n minus 2n minus of this guy. So 2n plus 1 minus 3r, that guy factorial. Just divide by like that, right? So it's gonna be r plus 1 factorial, and then you got n minus r minus 1 factorial. This is somehow equal to 1, right? Ooh. Now think about it. What can we do? It's got n minus r minus 1. Oh, okay. What am I doing? Why even go for this thing? You know how it is. You know how these actually work, right? You don't have equality everywhere except when these are complementary, right? So this will be like when you have 3r minus 1 is equal to r n minus that guy. Or maybe I should just say this plus r plus 1 is equal to n. Only then can these be equal. Doing it with all of that methodical thing, that's not good. Just guess and find a value. And in the end, that's just what it's going to be. Like, I mean, like, see the Pascal's triangle thing. Only the ones which are equidistant from the center will be equal. All of the other terms will, I mean, yeah. So going to the center, it's increasing throughout. So you don't have to worry about somehow those terms while increasing being equal. That can't happen, right? So this is the thing. 4r is equal to n basically. So, r should be just, yeah, well, that's right. R should just be n upon 4, huh? So, how did that happen? It's supposed to be 2n. Sorry. It should be 2n. So it's gonna be n upon 2 now. So yeah, A is the correct answer. Let's go to fourth. The term independent of x in the expansion of this is, right? So we've seen this so many times. Fine. So it's gonna be what, like 18 is equal to 2r plus r. So it's like r is equal to 6. R equal to 6 term, that's the 7th term. So C is the answer. Wow, this was quick. For the 7th term, we will have r equal to 6. So this will be 1 upon x power 6, and then you got x squared power 3. It works out, right? Independent of x. Fifth. Okay. If the third term in the binomial expansion of this quantity is this, okay, then the rational value of m is, oh, okay. Well, I'm guessing it's gonna be 1 upon 2 because that does give the third term like that, right? I mean, look at this. The first term is going to have quotient of 1. The second will have 1 upon 2. Yeah, and the third term will just have 1 upon 2, negative 1 upon 2, that upon 2, which is going to be negative 1 upon 8. So that's why B will work. And yeah, I mean, all of the other terms are just like integers, and that doesn't ever give this thing. You just get integer coefficients and negative. Come on, how can that happen? So B is the only correct thing by far, in fact. Last term in the binomial expansion of this is this. Okay, fifth term. What is this? So log base 3. Okay. So we'll have to write as 3 power something. So you got 3 power negative 1, and then you got 3 power negative, well, I think 2/3. So like 3 power negative 5/3, and all of that to the power of log base 3 of 8, which is like 3 log base 3 of 2. So this cancels. You get 2 power negative 5, right? So you're saying the last term in this expansion will be 2 power negative 5. Okay. Yeah. Right. But wait a second. But that would mean like, how can that be though? Wait, what? It's got to be 2 power negative 5, but then, okay, no big deal. I get it. N should be 10 so that this happens, because then the last term will be, the last term will be when you got 1 upon square 2, so negative 1 upon square 2 to the highest power, to the n power, and that has to be 2 power negative 5. So like just got 2 power negative 1 upon 2 to the power of whatever. So the magnitude wise is just going to be 2 power n upon 2 is equal to 2 power negative 5. Oh, sorry, negative, because 1 upon square 2, right? 1 upon square 2. So n should be 10, and that also kills off the negative in front of 1 upon square 2, and that's why it works out. So there we go, n is 10. Then the fifth term from the beginning is, so you mean like r is equal to 4 term, right? Okay, cool. So fifth term from the we call beginning or whatever, right? So the r is equal to 4 term, right? Just gonna do it. 10c4 cube root of 2 to the power of 6 Yes, that's going to be 2 power 2 because 0 upon 3 is just 2. And then you got negative 1 upon square root to the power of 4. So that negative is gone. But 1 upon 2 power 2. Cool, cancels away, right? It's just going to be 10c4. So there we go. Oh, I think something went wrong. It's going to be 10c4 over here and huh, from the beginning, of course. That was unexpected. How did this happen? It's going to be 2 over here. So why isn't any of these just 10c? That's 10c6 over here. It's just assuming as 10c4. Well, that's not correct. How can it be 4 over here? That's not. Fifth term from the beginning. What? So you got to have 4 over here. So 1 upon square root of 4. That's got to be 1 upon 2 squared. And then cube root of 2 power 6. That's why it's going to be 2 power 2. And that's how it just becomes 10c4. Now, none of these values is 10c4. So you have to go for D. That's the only thing that you can say. So yeah, 7th. In the binomial expansion of a minus b power n and bigger than or equal to 5, sum of the 5th and 6th term is 0 and a upon b equals. Oh, so like these are opposite. That's all it actually means. So you can just figure out what n is. I mean, magnitude wise, these are the same. And of course, these are consecutive, so they're going to be opposites. Right? I mean, in sign, they're going to be opposite. And magnitude wise, these must be equal. That, what does that even mean? Yeah, then a upon b equals what? Fine. So and c 6 times so negative b power 6 or whatever. So let's take the magnitude anyways, like a power n minus 6, and then you got b power 6 over there. Oh, okay. So when this is the 5th and 6th term, they actually mean this thing. It should be 5 over here. Sorry. Yeah, like 5. We got 4 in the next thing, so 4. A power n minus 4 and then b power 4, that thing has to be 1. That's what you're saying. So this whole thing is going to be a, and this thing is going to be b, and then nc5. Yeah, like a upon b is just going to be nc5 upon nc4, which is, so n minus the smaller number, n minus 4 upon the bigger number, which is just 5. That's the thing. So that's what we're looking for when we say a upon b. So n minus 4 upon 5, which is a. 7th, a. Next, 8th. The number of real negative terms in the binomial expansion of this thing. Okay, real negative terms. Cool. So 1 plus ix to the power of 4 and minus 2, huh? And belongs to integer or whatever. So if we talk about this guy's expansion, it's going to be like 1, then you got ix, which is so not good. So the second term is imaginary. The third term will be negative. So like let's go with first, second term, third term, fourth term, fifth term. Yeah, first term, not the r equal to 1 term. The first term, that is real and it's positive actually. So like it's positive. Second term is imaginary. Third term is negative, right? Yeah. So we want the real negative terms. And the fourth term will be negative imaginary. The fifth term will be positive. So you see the pattern. First is positive, fifth is positive, and so on. So like it's got a jump of 4, of course. So it's like 1, 5, so on till you eventually get something, and then you will have in the end just 4 and minus 2. So it's jumping by 4, and total there will be like 4 and minus 1 terms. Yeah. Okay, cool. So 4 and minus 1 terms, you say. And then it's jumping like that. How many jumps do we have to take before it reaches 4? I mean, it's actually never going to reach 4 and minus 1. The thing that it will reach though is just 4 and plus 3. Oh, sorry, 4 and plus, sorry, 4 and minus 1 plus 1, which will be like 4 and minus 3. Yeah, that's right. So n minus 1 and then plus 1 is 5, 4 minus 1. Right, it will reach over there. It will go to 4 and plus 1, might go to that, but then you don't have this term actually. So you just have 4 and minus 1, right? That's the limit. So you just have those many terms. So yeah, all of these terms, just want to count how many are there. It's like 1 plus, what's the difference? 4n minus 4, that upon 4 is going to be n minus 1. There we go, it's going to be n terms. Cool. So a, it was weird. How did it turn out to be n somehow? Fine. This is the positive terms. Okay, this is wrong. That's not correct. We want the negative terms. So you should actually start off at 3. So it's going to be 3, then 3 plus 4, got 3. Yeah, like these terms, 3 plus 4, 3 plus 8, so on. So it's like 4 times something plus 3. And then you got 4n minus 1. Well, 4n minus 1 is also just, it can be written as 4 times n minus 1 plus 3. And that's why it also works. So 3 plus 4 times of n minus 1 right there. So it's like it start off at 0. So 3 plus 4 times of 0. And it ends at n minus 1. So it's going to be n terms. This was weird. So even then it's just n terms. So my answer would have been correct even then if I did make that mistake. Okay, 9th. The question of question of t power 32 in the expansion of 1 plus t square power 12, 1 plus t power 12, 1 plus t power 24. And you want t power 32 over here. Alright. It's gonna be weird. It's got like 1 plus t power 12 plus t power 24 plus t power 36, which I'll ignore completely. And it's got 1 plus t squared power 12, right? So to combine with 12, you would need 20. So you would need that. Oh, and also like 24 is the maximum you can get from here, right? So you can never get something for this 1 because that would need to be our 32, which is not possible over here. So you will start off at this directly, for which you just need 20. So for 20, you just need t square power 10. So it's going to be 12c10. That's that coefficient. And then plus. So for 24, you would need other part would just be 8. So for 8, you would need t square power 4. So it's going to be 12c4. Which is like 12c2 plus 12c4. Oh yeah. Oh, in fact, you just gave us the answer in this format. So A is correct. Cool. So 9th down, let's go to 10th now. 10th is the coefficient of x in the expansion of 1 minus 2x cubed plus 3x power 5, and then got 1 plus 1 upon x power 6. Okay, cool. So for 1, you would just need x, which is not present in this 1 plus 1 upon x power 6. For negative 2x cubed, you would need a 1 upon x cubed over here. So that's going to be like a negative 2 times 8c3, right? So 8c3, and then you got 1 upon x cubed, and that times negative 2x cubed. So that's going to give us something that has, it should not be like, it should be 1 upon x squared. Sorry for this, really sorry for this. It should be not this, it should be 8c2. Yeah, that would be doing it, because then you'll just have 1 upon x squared, not this x cubed. Yes, yes. And then you got 3x power 5, for which you will need 1 upon x power 4. So that will be like plus 3 times of 8c4, huh? Well, that should do it. So this will be our coefficient. Okay, that's a lot of calculation now. Fine. So 8c4 is going to be 8 into 7 into, or maybe like I can somehow simplify. I don't think so. I don't think it's simplifiable directly. Just do it. So 8 into 7 into 6 into 5 upon 4 into 3 into 2, right? This cancels with that. This cancels with that, just 2. So 70. This whole thing is just 70. So 3 times of 70. Minus, so 2 times of 8c2, which is like 8 into 7 upon 2, which is, that cancels with that too. So it's just 8 into 7. So it's going to be minus 8 into 7. Cool. So take that 7 out, it's going to be 30 minus 8. Right? It's not point, it's a multiplication. Okay. So 30 minus 8, which is just 7 into 22. That should make sense. So it's just 154. So C is the answer. Then you got 11. Number of irrational terms in the expansion of square root 2 plus square root 3 power 15. So the way it gets irrational is that both square root 2 and square root 3 have some odd power. Only then will this actually be irrational. And so only when these have both have even powers will we get a rational term. So when do these have? Oh, these cannot ever have. I mean, both of them simultaneously can never have even powers, because then it would be like even plus e1 is equal to 15. Makes no sense. So all of the terms will be irrational. Wow, that's nice. That just means like 16 terms. All of these 16 terms. So a 12. In how many what? In how many terms in the expansion of this quantity? Do not have, so why did they put n over here? How many terms in this expansion do not have fractional power of the variable? Right, so x power 1 upon 5 should not have a fractional power. This means x to some power of like x power 1 upon 5 to some multiple of 5 basically. And then y power 1 upon 10 should have a multiple of 10 as the power, right? So I think y power 1 upon 10 is easier to deal with. Or let's just go with this thing. Let's think about it. So, oh, come on. Is that lagging though? Okay, whatever. So if the power of x is say 5p and the power of y is 10q, then these should add up to what? 255, and each pq pair will correspond to a different term, right? This just becomes like p plus 2q is equal to 11, right? Exactly, and p, q are just whole numbers. That should make sense. Cool. So now, how many solutions of this thing, right? Yeah, just start off with one solution and then you will keep on going. So I think, well, q, okay, p cannot be 0. P has to be 1 at least. So p has to be 1, and then plus, if it's 1, then q can be 5. And then, like, of course, p just has to be odd, because look at it. Just look at the equation. Then the next will be 3. And then for that, you just have, so 4. And you can see the pattern. It's going to be 3, 2, and 1. And you'll have 0. So you'll have 11. You got 5, 7, 9, 11, right? So these are all the PQ pairs. There we go. It's just 6 pairs, and that's why 6 terms in this will have integer powers of x and y. So there we go. 12a. Let's go to 13th. If the coefficient of 5th, 6th, 7th term in the expansion of 1 plus x power n are in AP and the value of n is exactly. So for this, I even made a whole fucking. I made a formula, right? Yeah, I even made a whole formula. So the formula, as much as I can remember, was n is equal to, I think, 4r plus 1, because 21. That's what we got last time, and we got 49 in the end, right? So that was like 8r plus 9. That's why you got 49 when you put r is equal to 5 in there, and that upon 2, right? That was the thing. So when r was so R is belong. I mean, it's like if you got NCR minus 1, NCR, and NCR plus 1 in AP, right? So basically the R term, the R plus 1 term, and R plus second term in the AP. Let's put R into this thing and get the value of N. In this case, R will be 5. Wow, this is like the same thing. So we just know it's like, yeah, we just know the value. It's gonna be A. This will either give us 7 or 14, because look at this, is going to be 21 plus minus of 7 upon 2. So you could have, it's like 7 into 3 plus minus 1 upon 2. So you could have 4 upon 2 should be 2, and 2 upon 2 should be 1. So 7 and 14. They didn't give us 14, but that's also a value. So in options, just A1. A is like correct. That's the only correct thing. 14th, huh? If the third term in the expansion of this, what is this? X plus log base 10 of x, wow, is equal to this. Okay, it's not that bad. It's just a normal equation. It's like 5c3 x power 2. Sorry, the third term would mean r is equal to 2. So that would be like 5c2 and then x power 3. And then you got x power log base 10 of x, whatever. That is the power of 2, right? This thing is somehow equal to, what's this? So 1, 2, 3, 4, 5, 6, 0, so like 10 power 6, there we go. It should happen. So x power, oh, and by the way, what's 5c2? 5c2 is just 5 into 4 upon 2, which is like 10. Wow. That means x power 3 plus 2 log base 10 of x. That is 10 power 5. So just guess something. Right, x is probably just 10 because this will satisfy the whole equation. So x should be 10, I think. But no such x-axis is like really false. One of the solutions is 10. There might be more solutions which we don't know of. Whatever. 10 squared, I don't think that will work. So no, I mean if you put any bigger power of 10, it will just become larger, and that just won't work, right? So it has to be just like that. Okay, let's go to 15th. Yeah, that's how it should be. Okay, 15th. If sixth term in the expansion of this is 5600, then x is equal to. Okay, so six terms like are equal to 5. So 65, and then you got x power negative 8 upon 3 to the power of, well, the power of 5, I guess, because sorry, no, to the power of 1. Yeah. And then this thing to the power of 5. And you got log base 10 of x to the power of 5. Yeah. This is equal to 5600 somehow. Well, I'm guessing it's like probably x is equal to 10 will work once again. What's 65 just 6 basically. So this is equal to what? 5600. So you got this upon 6, and that's not good. Okay. This is bad. It's upon 6. Okay. Now what do we do with it? I mean, x being some multiple of 10 probably won't work. Yeah. Something else. What about square root of 10? Okay, no, just don't try that. X is equal to, I don't know, man. I don't know. X power negative. Okay, let's just try each of these options. So if I put 5 in there, this is like x power, so 5 power negative 8 upon 3, and then 5 power 10, and you got, well, log base 10 of 5, which honestly, how can you even do that? That being equal to this thing, that's not correct. That would be like saying you can find log base 10 of 5 as a radical, and I mean, no, that's not correct, right? Yeah, that's not correct. You can definitely write this like natural log of x and one natural log of 10 and stuff, and just getting more complicated. So I think it's good enough to say it's like none of these, right? Because I mean, look at these values. Why would any of this work? You got log base 10 of something that is not a multiple of not a power of 10, and then equal to some radical, right? Something like that. No way, that can't happen, right? That just cannot happen. So that means 15th D should be correct thing. If we knew something like that, then you would be using that approximation everywhere in physics, right? But we don't, so that's small. I mean, it's not even an approximation at the point. If it is equal to that, it's like actually equal to that. But we don't know anything such as that. So most likely none of these. Okay. If in the expansion of 2 power x plus 1 upon 4 power x to the power of n, t3 upon t2 is equal to 7, and the sum of the coefficients of second and third term is 36. The value of x is. Wait. Is that 6 over? Okay, just no, that's 8. Oh, so 15 was okay. This was really bad. Oof. But still, I mean, like these values probably don't work, you know. Anyway, the 6 term like the r equal to 5 term, and this is 8 for some reason, I think. That should be 8. Yes, that looks like 8. So 8c5, and then you got this to the power of 3, so x power negative 8, and then you got x squared to the power of 5. Yes, that's going to be x power 10, and you got this same thing, so like log base 10 of x to the power of 5. That's equal to 5600. Now 8c5 is like 8c3, which is just 8 into 7 into 6, and then upon 6 basically, like this cancels. 56 basically. So there we go, getting something nice. Just me 100, so 10 power 2. I'm guessing the only way this could probably work is like if x was 10, right? Because this is like x power 2 times log base 10 of x to the power of 5 is equal to 10 power 2. So if x was 10, it would work, but none of these are 10. So yeah, D. There we go. Okay, let's go to 16th. If the expansion of this, okay, if t3 upon t2 is equal to 7 and the sum of the coefficient of second and third term is 36. Okay. So second and third term is 36. The final value of x. Oh, come on. Seriously. Fine. So like t3 upon t2, it's gonna have c3 upon c2, and then so while going from there to there, you delete one 2 power x, and then you make a 1 upon 4 power x appear. So basically you are like multiplying by 1 upon 8 power x, right? So like 1 upon 8 power x, and then c3 upon c2 is just n minus a smaller number upon the bigger number, and that's equal to 7. That's what we're saying. And we are also saying that the sum of the coefficient of second and third term, so just the coefficients, huh? So like r equal to 1 and r equal to 2, some of those things. So that will just be like nc1 plus nc2, right? That is 36. Then the value of x is so you will have to solve this equation together with n, and then you will have this, and you can solve for x in that case. Fine, let's do it. So this will be like n plus, wow, this is just really bad. N into n plus n minus 1, it's like n square minus n, that upon 2 is equal to 36. So n squared minus, so 2n minus n is just plus n is equal to 72. That should work, I guess. That's like n into n plus 1 is equal to 72, which is basically like 8 into 9. So you get it, n should be 8. Once n is 8, you can figure out what this is. So 6 upon 3 is 2. There we go, this whole thing is just like 2. Wow, this is weird. Why is this 7 of all things? And this is not like that. Why is this 7? I don't understand this. T3 upon T2. Oh no, okay, this is wrong. This is like really wrong. T3 upon T2 is not this thing. It's basically like C2 upon C1. Right. Of course. So C2 upon C1, which is like n minus a small value is just 1 upon the bigger value. That is equal to 7. And now thing is n is 8. So this will be like 7 upon 2. So yeah, this. So 8 power x is equal to 1 upon 2. Oh yeah. So x is just equal to negative 1 upon 3. So A, 16th A. 17th. Middle term of the expansion of 2a minus a squared upon 4th power of 9. So middle term, you said. How many terms going to be? There's going to be, yeah, it's 9, right? So there's going to be 10 terms. Oh, okay. Yeah, sure. So like 2 terms over there. Cool. You just need 9c5 and 9c4. Both of those. Just do the 9c4 first. So 9c4. And then you got 2a power 5. And then negative a squared upon 4 power 4. Which will be like a power whatever that is. Yeah. So a power 8 upon 4 power 4. And this is like 2 power 5, a power 5. Okay, first of all, let's figure out what 94 is, because we'll use that. 9 into 8 into 7 into 6 upon 4 into 3 into 2, which cancels with that to get 2 over here. 18 times 7, I guess, which is like 76, 126, right? So 94 is just 126. Yeah, like, and that should work. Okay, now this thing is like 2 power 5 upon 4 power 4, it's like 2 power 5 upon upon what? Upon 2 power 8. So that will be 2 power negative 3. And then you got a power, what is this? 5 and it's like 13. So yeah, then you got 126 right there. Other term will just be, well, we'll deal with that later on. So what will this be? Just 126 upon 8, which is, so it's 32 upon, okay, so you can just divide by 8 directly. So only 1 and 8 right there. 1 and 36. Oh, this doesn't work. It doesn't work like that. You gotta divide by 4. That's the only way, huh? It's gonna be, but okay, this is weird. Divide by 4, it will be like, oh, you cannot divide by 4. Okay, that's where I was going wrong. So this is going to be just 93 upon 2 power 2, which is 4. 93 upon 4 times a power 13. That's the first term. Is it there anywhere? No, you got 60. Oh, sorry. It should be 63. What am I doing today? 63 upon 4 and then a power 13. So 63 upon 4 a power 13. Well, that's everywhere except you have negative, positive, and something. Oh, okay. So look, these two get cancelled. Well, okay, no, only B gets cancelled. So you need to figure out the 5 term as well. And you got a power 13 over here, right? Okay, so that's only in B. B is actually cancelled anyway. So it's just in C and D. So in C and D, you have this. Just need to figure out what this is, like 32 or 4. Okay, cool. So then you just have 126 and then you got, so in the next one just have 2 power 4. Okay, and then upon 4 power 5. Wow. And a power 4 and a power 10, which is 14. Okay. Whatever. And this is like 126 upon 2 powers. It's like 10 minus 4, I think, so 6. This will be 9, not 9. 63 upon 2 power 5, which is 63 upon 32. So there we go. This thing, C is the correct answer, I think. So 17C. Let's go to now 18. 18 is, if x plus y is equal to 1, then this sum, so summation from r is equal to 0 to n r squared ncr is power r y power n minus r. There's an r squared over there. That's complicated. Well, that's okay. This is like not good. X plus y. This thing. But I mean, you know, it's just x plus y to the power of n is equal to summation from r is equal to 0 to n of ncr x power r y power n minus r. I mean, I can put it in whatever order I want. What I'm thinking is, well, differentiate this with respect to x first. That will just be n x plus y to the power of n minus 1 is equal to summation from r is equal to 0 to n of well, r ncr x power r minus 1, and then you got y power n minus yeah, and then just multiply by x once again. So we'll just have this thing and then differentiate once again. Boom. Yeah, so differentiating once again with respect to x, that is, it will be like n into n minus 1, that times x plus y to the power of n minus 2, and x, then plus x, and like n into x plus y to the power of n minus 1. Exactly. And then when you differentiate, just get r squared and c and all that stuff, but that times x. So this will be the thing we're looking for. So this is the expression, and you just need to figure out what this guy's actual value is. So this will be 1 anyway, and get rid of all of that. So this just becomes nx into n minus 1 times x. So yeah, nx minus x, and then plus 1, I guess. Yeah. So 1 minus x is just y. So it's going to be nx times nx plus y. Exactly. So C looks correct. Yeah, I think so. Okay, let's go to 19th. Is this multiple choice? No, it's got to be single choice, right? It says 1A is mostly just single choice. So let's go to 19th now. Given that the fourth term in the expansion of this quantity has the maximum numerical value, the range of values of x for which this have I oh we have already done this question once in the past, right? Yeah, in the interpret exercises we already did this. But anyway, let's do it once again. So fourth term means r is equal to 3. Figure out the a for this guy. So it's going to be n plus 1, which is 11 upon 1 plus mu. So that will be, so what's mu by the way? Yeah, it's just like 16 upon 3 mod of x, but I'll just write 16 upon 3x. Now this thing is bigger than, so a bigger than r, which is so 3, and then 11 upon 1 plus 16 upon 3x minus 1 is less than r, so less than 3. That means it's like less than 4. Okay, now let's figure out what values of x will get. And here it's supposed to be mod x, so it will be positive. Just do that. So yeah, 11 bigger than 3 plus 16 upon x, right? So it got 8 over here. So x is bigger than 2. That should do it. And from here, just get 11 is bigger than 4 plus 64 upon 3x. So this will be 7 bigger than this. Like x is less than 64 upon 21. And these are just this I'm saying it's x, but it's actually supposed to be mod x. So this is really just mod x belongs to, so it's less than this quantity 64 upon 21 here, and then bigger than this quantity, so 2 over 64 upon 21. So mod x belongs to this thing. Of course x will actually belong to the different range. Yes, yeah, I mean it will belong to this, and at the same time just negate this whole thing. That will also work. So I mean, of course 64 upon 21 is bigger than that, so negative of that will be less than that. Yes. Okay, so C is just wrong, B is also wrong, A is the only correct thing. It's not a full set, but it works at least. Let's go to 20. The greatest value of the term independent of x in the expansion of this, okay, is, so greatest value of the term independent of x in the expansion of this thing. Right, fine. So it's just the r equal to 5 term, of course, because you got x and x power negative 1 and whatever, right? So it's gonna be like 10c5. Then you got sine power 5, and then you got cosine power 5. That's it, huh? Isn't that right? And then those x values get cancelled. So yeah, so what the greatest value of this term? Well, sine cosine has the greatest value as 1 upon 2. Yes, because this is like sine cosine can be written as 2 sine cosine upon 2, and then this has the greatest value as 1 because it's sine of 2x or sine of 2 alpha in this case. So it will have biggest value as 1, and that's why 1 upon 2. So you just got 1 upon 2 upon 5 as the greatest value. So 1 upon 30. There you go. And 10c5 is like, okay, 10 into. Do we have to do that, or just okay, just give it like that, huh? Oops. So this will be like 10 factorial upon 5 factorial squared, and then you got 2 power 5, which is C. Okay. 21st. The greatest term in the expansion of 2x plus 7 to the power of 100, part 10, where x is equal to 3. Right? So once again, if you out what the mu is and everything, and do it. So our A will just be 11 upon 1 plus mu, which is 1 plus, so first term upon the second term, right? And yeah, like because in normal notation, it's just a bunch of notation that you have to follow, right? I just hate it. It's like talking about something with rules that are just, seemingly arbitrary, isn't that right? Anyway, let's do it. So mu will just be 2x upon 7. Yes, and here x is just 3 basically, so it's like 6 upon 7. Okay, so that will be 77 upon 13. So what's the decimal value of this thing? So like 77, but 13 over here. I guess 6 will probably, no, okay, that's not right. 78, right? So 13 times 8 will be 78. Sorry, 13 times 6 will be 78. Yeah, so this thing is slightly less than that. So slightly less than 6. So it's like 5 point something, whatever. So r is equal to 5 is the way to go, because a minus Yeah, a will be 5 point something and a minus 1 will be 4 point something. So between that, the integer is just 5. So the r equal to 5 term, that is the sixth term, right? 21st, b. Let's go to 22 now. Okay, guess this works out. Yeah, 22. Yeah, that should actually work out. Okay, so if 3 power, what is this? N minus, so n1 minus n2, okay, 3 power n1 minus n2 of p2 is equal to 3. What is this? N1 plus n2. Oh, it's permutation. Okay. I understand what's happening. Uh-huh. And that's equal to 90 in the order pair n1 n2. Ah, come on. Are you serious? First of all, their notation is just really bad. And secondly, I mean, they didn't actually introduce permutation right now. So how can they even use this symbol? I don't know. Anyway, just give it a try. So first equation you have like n1 plus n2 p2 is equal to 90. So that's just like n1 plus n2 times n1 plus n2 minus 1. So actually you can just figure out what the n1 plus n2 value should be. So call this thing as x for now. It will be x squared minus x is equal to 90. In fact, you know what? Since these are going to be integers anyway. Yes. So what we can do is just guess. So n1 plus n2, that should be 10 most likely. So that n1 plus n2 minus 1 would be 9, and this will work out. So n1 plus n2 is equal to 10. And then n1 minus n2 p2 is 30, which is like 6 into 5, right? So the bigger number will of course be n1 minus n2, which will be 6. So there we go, n1 minus n2 is equal to 6. That makes sense. So just add this up. So yeah, n1 is equal, so just write the order pair directly. Add 16 upon was like 8, and then subtract 4 upon was like 2. So 8 comma 2, huh? So a 22a 23. If n minus 1 cr is equal to k square minus 3 times n cr plus 1, then k is, so k belongs to its range. Okay. Oh, got n minus 1 cr, and of course, so you can use that fact that we just I mean, we did this, right? We already did this. It's just n plus 1 cr plus 1 is equal to n plus 1 upon r plus 1, and that times of ncr, right? So I mean, just writing out the actual formula, the short formula for doing this, it's like n plus 1 times n and all the way till r plus 1 terms, and that upon r plus 1 factorial, that can be done as n plus 1 upon r plus 1 times n and so on till r terms upon r factorial. And that's why this thing. Now I'm just going to use this fact to find out n cr plus 1 upon n minus 1 cr. So it's the same thing as like 1 is equal to k squared minus 3 times n upon the bigger number is r plus 1, of course. There we go. Okay. So if this happens, then k is, I mean, come on, this is weird because you didn't actually tell us anything, in fact. Oh no. All it's saying is just that k square minus 3 is equal to r plus 1 upon n, right? That's all it's saying. Now, what do we know? R can at max be n minus 1, right? Because r plus 1 should be less than or equal to n. So this thing is just less than or equal to 1. That's all you are saying. Is that so? So then k squared is just less than or equal to 4. Okay, it's charging. Just wait a second. Cool. Which just means, okay, k just belongs to negative root 2. I mean, close bracket, right? That should do it. So, okay, that's not here for some reason. Huh. It's k square minus 3 right there, and that's supposed to be 1 and why would it not work? And of course it's positive and everything. Okay. Oh, okay. K squared minus 3 is also bigger than 0, right? So r plus 1, that kind of quantity actually, yeah, well, that should be bigger than or equal to 0. So that's why they are not equal to 0 as well. So k squared is also bigger than or equal to 3, and that means k is either bigger than square root 3 or equal to, or k is less than or equal to negative square root 3. So the whole range would in that case be just, and like negative square root 3 is less than, sorry, square root 3 is just less than 2. So yeah, the thing is, it's going to be negative 2 to negative square root 3 union square root 3 to 2, right? That's what the range of k will be actually. So which of these actually works out? I guess this works. So D works, yes, of course. And okay, I mean, if R plus 1, okay, yeah, that won't work. R plus 1 cannot be 0. It cannot be directly equal to that. Instead, it has to be strictly bigger than that. So it will actually be like this. Because if R is somehow, yeah, I mean, if R plus 1 is somehow 0, that means R is equal to negative 1 and n minus 1 C negative 1. That doesn't make any sense, does it? Yeah. And that's why R actually has to be equal to 1, right? Yeah. Sorry, sorry, R plus 1 has to be equal to 1. That makes sense. Okay, that's why this is a round brackets. And that means D works, just D works out of these options. Because it's a part of this set. So it might belong to this thing. That's what you're saying. Well, okay, so C is just really bad. And B, I mean, it not necessarily, but okay, whatever. Thing is, we don't know if k is positive or negative. If it was positive, then it will be D for sure, but it's not necessarily positive. He should have given the whole set, but they didn't. Okay, 24th. Like this statement that k belongs to this set, it's actually very restrictive. It should be more free, in fact. And all of these statements are actually very much restrictive because, yeah, okay, whatever. Okay, let's go to 24th. If NPR is equal to 5040 times n minus 1 CR minus 1 plus n minus 1 CR, then R is equal to, come on, are you serious? Like n minus 1 CR minus 1 plus n minus 1 CR, it's going to be NCR. So it's like saying NPR is equal to 5040 times NCR. What is this really? This is going to be like n factorial upon n minus r factorial. So the order of the disselected stuff doesn't matter over here, but the selected stuff does matter. And then you got 5040. You get the idea. It's going to be r factorial. So this whole thing is just r factorial. So right, 5040, and then you got n factorial upon all that stuff. So this is supposed to be r factorial. Now we'll just prime factorize this thing and factorize this thing, and we'll see what we get. So yeah, like 5040 should be r factorial. What will r be? That's the question, huh? Let's do it. 1 factorial is just 1, 2 factorial is 2, 3 factorial is, well, I mean, it has to be greater than 5 for sure, whatever. 3 factorial is just 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, I guess. Okay, 7 factorial is like 0, 4, 1 carried on. Oh yeah, it's just 5040. So 7 is the way to go. So 24th is C. Cool. Let's go to 26. Sorry, 25. The value of 35C8 plus summation from R equal to 1 to 7 of, what is this? 42 minus R C7 plus, okay, so from R equal to 1 to 5. You have to do this summations differently. So it's just like, okay, 42 minus R. So when R equal to 1, it starts at 41. So 41 C7 plus 42 C7 and then so on, right? Then you will eventually get, when you put 7 over there, it will be, if you put 7, it will be, so 30, what am I doing? 35 C7. Okay, so the thing is, you will also have 36 C7 over here. Another thing is like this plus that is just it's just Oh, it's slightly different. Yeah, because it is really different actually. Hmm. That's weird. Oh, and what is this summation going to be? And you also have this 35C8. Oh, you can use this directly. So 35C8 right there. Oh, cool. And yeah, so this thing 35C7 plus 35C8, that will just be 36C8, and then this combined with that will give us 37C8, and so on. You get a chain effect, and then in the end, it's gonna get 42C8. Okay, cool. So the first term and the series, the second term, okay, those combined just 42C8. Now let's go to the third one. So this summation. So it starts off at 1, huh? So 46C, well, 39 or something. What? Hmm. Oh, okay, this is different because like 47 minus RC, 40 minus R, that's the same thing as 47 minus RC7. So 46C7, right? Yeah. And then you start off with going, in the end, you're gonna get 5, so 42C7. Now, the same thing once again, this and that, right? In the end, you're gonna get 47C8. That's the thing. So A is the answer, 25th A. So you're just using like Pascal's identity to get this done. Sometimes it's also called like hockey stick identity. No, that's the chain form of this thing. The Pascal's identity is the short form, maybe more fundamental one as well. 26. The coefficient of x power 65 in the expansion of this guy. Okay, so 1 plus x power 131 and you got x power. Hey, I've seen this somewhere. So like this is just 1 plus x times 1 plus x power 130, and then you can bring that inside, and that will just be well, like 1 plus x cube to the power of 130, right? And you just want the coefficient of x power 65. I have seen this before. I don't know. Anyway, for 1, you would need a 65. So 65 upon 3, that's... Oh, 65 is not a multiple of 3. Okay, so you cannot have x power 65 in this expansion itself. So that one thing, you can't do anything for that. But for x, you would need 64, which is also not a multiple of... Huh, that is not good. It's also not a multiple of 3. But why? I don't understand this. Okay, this is not here. So it's 0 actually. 130, got x cube right there. What? For x, you would just need x power 64, which somehow happens to not be in this guy's expansion. So now what do we do with it? Which is going to be all multiples of 3. So it's like whatever in the end you get after doing all of this, you will just get x power. Okay, so the power of x will be of the form 3k and 3k plus 1. But 65 is like of the form 60. So this is like 63 plus 2, which is of the form 6 of the form 3k plus 2. And yeah, this is not okay, right. Thing is 0. 0 is the answer. None of these. Okay, B. That's it, huh? That's it. All right. So let's go to 27. Number of terms in the expansion of x plus y plus 2z to the power of 8. Okay, cool. So yeah, it's number of terms in that as expansion. Fine. It's gonna be like x power something. So x power a, y power something, and then you got 2z power something is equal to oh yes, like that's just the general term, and then you got a multinomial coefficient and everything. Thing is, the powers will be like that. Now, each of these ABC pairs, so A, comma B, comma C, this ordered list, this will give us a term, right? Each of this thing will give us a distinct term. And of course, you just have A plus B plus C is equal to 8 because homogeneous and everything. So, number of ways to do this. So, to actually write down number of ABC ordered list such that the addition is 8. And well, they can also be whole numbers and stuff, so a can be 0 and b can be 0 and whatever. So it's done by the star bar theorem, which is okay. I don't know if you have seen it, but you should really see my combinatorics playlist, because there I did talk about the star bar theorem and all of the other stuff. So, and also permutations. If you have doubt regarding that, go see that. But the star bar theorem basically says that if you have 8 stars and so like ABCR, you can think of it, you can think of them as containers, and then you just have 8 stars lying in a line or something, and you want to put these 8 stars in these 3 containers. So these 3 containers are like labeled ABC, I don't know, something like that. So we can do that easily by basically taking 2 sliders. What do I mean by sliders? So I'll just take a bar. So the slider is just a bar, and then you change its position and insert this bar into this line. So between 2 stars. So if I say insert it over here, then all of these stars before this bar, those will just go into A. Now once I have done this thing, I will take another bar, and then I will insert, like maybe it's yeah, got 8 stars, right? So maybe I will take another bar and then put a bar over here. So all of these, so these 2 stars will go into the second guy. So you got 2 over here, and you got 3 over here, and then the remaining 3 will just go over here, right? So number of ways that we can insert these 2 bars will be the number of ways that we can get ABC, because each of these kind of, you know, configuration, it gives us a distinct ABC, right? So number of ways to do that is just, well, 8 plus 2 C2, because there are total of 10 characters and then 2 bars. So you just want 2 places to put these bars in, and then the remaining places will be filled by stars. That's the number of ways that you can form this kind of configurations, and then you will have those many ABC order lists as well, and that many terms basically. So it's going to be 10C2, which is like 8 into 7 upon, sorry, what am I doing? 10 into 9 upon 2, which is 45, I guess. So A. Okay, cool. Now let's go to 28. 28 is number of distinct terms in the expansion of x plus 2y minus 3z plus 5. Come on. I mean, it's pretty much the same thing, you know, like just, yeah. So now you can do it easily. This is going to be n plus, now how many bars do we need? We just need, so there are a total of 1, 2, 3, 4, 5 terms inside the bracket. So you would need 4 bars. So 1 minus 5. Sorry, 5 minus 1. But you get the idea, right? So n plus 4, and then you got C4, right? So whatever is over here, the same thing over here. So n stars, 4 bars. So total of n plus 4 characters, and then 4 bars you have to choose out of this. That's why n plus 4 C4. That's going to be like n plus 4, n plus, I mean, I'll just keep it like that, not write it down. So there we go. B is the way to go. Cool. No cancellations, nothing. Yeah, that's the that's it. Yeah, that is just the thing. So D is not correct. Okay, so 4 factorial, and that's why it's got to be 24, not 6. Otherwise, it would have been correct. Okay, so you got B, and now let's go to 29. If the sum of coefficients in the expansion of 1 plus 2x power n is this, the greatest term in the expansion for x is equal to 1 upon. Okay. Sum of greatest term in the expansion for x is equal to 1 upon. Wait, what? So when you say the sum of coefficients, you mean, do you think of it as a polynomial of x, or do you think of it as a polynomial in 2x? I don't know. I'm just gonna think of it as a polynomial in x, not 2x. So we just put x is equal to 1 to get the sum of coefficients, because yeah, that's what we do. So it will be like 3 power n. 3 power n is equal to 6561. Now, is this the power of 3? So like 3 power 4 is just 81. 3 power 6 will be 729. 3 power I think 8, right? So that will be like 1, 8 carried on, you got 9, 2 is 18, and then 8, which is 26 over 6, and 2 carried on, and you got 63 and 2 is just 6, 5. So yeah, it is 3 power 8. So n should be 8. Makes sense. Okay. So now we have it, n is 8. And you want the greatest term in the expansion for x is equal to 1 upon 2. So what is our a value? It's going to be 8 plus 1 is 9. So n is equal to 8. Just write that down. It's going to be 9 upon, so 1 plus the mu, which is, oh, cool. So 1 upon 2 right there, huh? It's just going to be, wait, if it's just 1 upon 2, then it's like all the binomial coefficients are the only things, are the terms basically in the expansion. Exactly. All the terms are just the binomial coefficients. Isn't that right? So you don't have to do all of that in fact, right? So it's just the middle term, which is the 8c4 term, right? That will be the biggest one. So that means the fifth term basically. So 29p, 30. Coefficient of x power n squared plus n minus 14 upon 2 in this thing, okay, is, so you got x minus 1, x squared minus 2, x cubed minus 3, and so on, huh? Okay, and you want x power n squared plus n minus 14 upon 2. Have I seen this? Like 14 can be written as, how many terms are there? There are just, this is really weird. What's the highest power that you could get? That will be n into n plus 1 upon 2, right? So start off at 1, go till n, which will be like n squared plus n upon 2. Now this thing is 14 less than that. So there are supposed to be 14 brackets where you don't take x, but instead you take the constants in there. Exactly. But that's a really hard thing to do, you know. Okay. How do we do that? 14 brackets. I mean, won't it depend on n though? Because, yeah, I mean, there's supposed to be, sorry, not 14, it's supposed to be 7 brackets, because, actually, no, that's not right. What is this? Oh, it's slightly different now. Okay, think about it. So if you want like the most number of brackets, sorry, the least number of brackets. No, it's gonna go with the most number of brackets. So you're gonna start off at n and go down basically, right? So like n squared plus t. Sorry. So like there's a missing power of x power 7 somehow. Yeah. So how do we get that missing power of x power 7? How did we get that power missing somehow? That will be when you remove some of the terms from yeah, so like some of these brackets won't give you the x term, it will just give us the constant, and then the x term that didn't give us, the product of those x terms, those must be x power 7. Exactly. So how can you build up 7? 7 can be built up as, so I mean there can be multiple ways to do it, right? Yeah, let's just start actually. So you can build up 7 as, well, first of all, 7 plus 0. There's no 0 actually. You gotta have at least 1, right? But yeah, I mean, you just have 7. So that also works, because you will have like all of the other brackets giving us something, and then you're not having 7. The 7th bracket not giving us anything, right? It will work actually. It will work perfectly. Yeah, that works. So 7 can also be written as, so if it's not 7, you can do something else. You cannot involve 8 or anything of the higher powers. Let's go to 6 then. So the next highest number will be 6. 6 plus 1. Then that's it. So with 6 you cannot have any other thing, so it has to be 1. You cannot write it in some other way. So that's it. And then it can also be written as, well, wow, this is really complicated, isn't it? Okay, yeah, what about 5? So 5 plus 2 works, but also 5 plus 1 plus 1. Okay, you cannot have repetition of the same thing, because that is not considered correct, because like how can two brackets with the same x power be missing? So not give you the x term, because there are no two brackets with the same x power. So that's just wrong. So no, this won't work. This is only supposed to be 5 plus 2. That's the only way you can do it. Okay. Then you can also go for 4. So 4 plus 3, that's the bigger one. And then you got 4 plus 2 plus 1, that's the other one. So you can also do this thing. And exhausted. Okay. Now let's go to 3. So 7 is equal to 3 plus, it's got to be 4, but we already figured out what it would be if 4 is involved. So we cannot involve 4, then you just have 3 plus 3 is also not involved. So 4 can only be realistic. 2 plus 1 plus, no, okay, it won't work. It won't work. So that's it. These are the only ways of doing it. Now each of these, so if you have 7 over here, that corresponds to x power 7 minus 7, not giving the x power 7, and instead giving the negative 7. So this will actually give us the coefficient, its contribution in the coefficient will be negative 7. Right? This guy's contribution will be negative 6 times negative 1. And you see that. You see what's happening, right? So it's going to be negative 7, positive 6. You got negative, so no, positive 10, positive 12. You got negative 8. Right. This will be the thing. So this will be 28 minus 15, which is 13. So 13 should be the thing. So question of x power, all of this stuff. It's going to be a. It's 28a. So 29. Oh, sorry. 20 supposed to be 30. A. Okay. 31. Yeah, I'm determined to do it till 45. Okay. 1 upon 1 factorial and got n minus 1 factorial. Ah, okay. This is just so silly. Just multiply and divide by n factorial and you'll see what's happening. It's just like NC1 plus NC3 plus NC5 and so on, right? So, like 1 plus x power n, so 1 plus 1 power n, that's 2 power n is equal to, you got NC0 plus NC1 all the way, right? And then you got 0 power n, so when you put negative 1 in there, just get NC0 minus NC1, and then so on. And then when you add these, you just get 2 power n is equal to 2 times of NC0 and all that. Actually, no, just not add it, subtract it. So that will be 2 power n is equal to 2 times of NC1 plus all of the odd R values. And that means 2 power n minus 1 is whatever this series is. So 2 power n minus 1 upon n factorial will be this series. Easy as that. There you go. So it's showing B. Yeah, B. Next. 32. 1 plus 2 upon 3 and then got 1 upon 2 and okay. So see this, you got 1 upon 2 right there, you got 3 times 6, which is like 3. Take 3 out of each of these, you just get, oh, and this thing is like 2, 5, 2, 5, 8 is going by 3 as well. I see what's happening. I see this, right? This is like 1 plus, let's go with this thing. So negative 2 upon 3 upon 1 factorial, then you got negative 1 upon 2. Then you got plus negative 2 upon 3, and since it's increasing, that's why I'm putting negative right there. So negative 5 upon 3, and just got 2 factorial, right? Because 3 into 6 taken out that 3 and 3, so you just get 1 and 2. Then you got 1 upon 2 squared, so it's like negative 1 upon 2 squared, yes. And so on, so you get the idea. It is just 1 minus 1 upon 2 to the power of negative 2 upon 3. Sorry, okay. So it's 1 upon 2 to the power of negative 2 upon 3, which is going to be 2 to the power 2 upon 3. Yes. That's B. Okay. 3. Okay. 33 is sum of the series 2 plus 5 upon, what's this, 2 factorial times 3? This is getting bad. 5 upon 2 factorial. Okay, now I'm just not going to talk. Okay. Hmm. 5, 3. Okay, difference of 2 right there. You will need to. This 3 is getting squared and everything. Fine. Oh, that's not supposed to happen. So we do need 1. Oh, okay, that's 2 factorial. Where is the 1 factorial? There's no 1 factorial? I'm gonna put a 1 factorial. And also 0 factorial. So I'll do like -1 plus 1 plus, or let's not do it. Let's leave it for the last step. First of all, 2 can be written as 3 upon 2. Sorry. Is that supposed to happen? No, it's not supposed to happen like that. It's supposed to be 2 upon 3. -2 upon 3 for the fact. Okay. I mean, like, look at this. Like, that's 3. That's yes. Then that's -1. Ah, no, that won't work. Right? Will it work? Each of these just has a 3. That's not correct. Oh, sorry. This is not how it's supposed to be. It's got 2 right there. Then it needs to have a 5. It's like 3 into 5 actually. 3 factorial. How can it be 3 factorial if it... Right. But squared. It should be cubed. Of course, so I'm going to rewrite every term. So first of all, with the third term, we'll start. It's going to be 3 into 5 into 7. And that upon 2. I'm going to divide it by 2 forcefully. Then it's going to be 2/3 cube in that case. Okay. Why did I 3 cube and not 3 squared? I'll show you. So because I have to multiply by this 3, I have to divide by the 3 as well. So we got 3 cube and this works out. We got 3 factorial, right? So more like -3 upon 2, -5 upon 2, -7 upon 2 upon 3 factorial. And you got 2/3 power of 3. Now, okay, you see how the term is going. Now, for the first term of this series, you'll have to write it in a similar way. So it should have the 3. So 3 into 2. Then, yeah. It should also have that 1 factorial. It actually should also have that 2 right there. So it's only 3 upon 2, -3 upon 2, and then got negative nothing. Okay, negative nothing. Then upon 1 factorial. And 2/3 power of 1 in this case. Okay. For some reason it's not working. Why is there a... Oh, that 2 is not here. You would need that 2 squared. Oh, okay. So while we did this one, the third one, I put a 2 cube over there, but that's not supposed to happen. Instead, yeah, wait, no, actually that's supposed to happen. Wait a second. Okay, since we just have the opportunity to do it as we wish, why not do it like this? 1 plus 1, and this one I will modify, and I won't modify the 2 directly, so that I can get rid of that 2 somehow. So it should be like 3, it's -3 upon 2, it's upon 1 factorial, and then this times 2/3, which is -2/3. Yeah, third one. The next, so we got 1 plus this guy, so this guy is just also 1, and that's why it becomes 2. Next term will just be -3 upon 2, -5 upon 2, -2/3 power 2, right? Upon 2 factorial. Look at it, it works out, right? So you got that 2, this cancels with that, right? This 3 cancels with that, so got 5 upon 2 factorial, and also this 3 because it's squared, so 5 upon 2 factorial times 3, and so on. So it's just going to be 1. Sorry. 1 is 2/3 the power of -3 upon 2. So it's just 1/3 power of -3 upon 2 is like 3 power 3 upon 2. There we go. So it's D, 32D. Oh wait, it's 33. Sorry. Okay, that's different. So 3 power 3 upon 2 is just 3 square root 3, right? So it's gonna be B. That's 33 right there. Okay, let's go to 34th. The coefficient of x in the expansion of 1 minus ax power -1, 1 minus bx power -1, and so on. Okay. I mean, this is just fine. So like if you could remove the x squared and all the higher powers, then what you would get. Basically like that. It's gonna be 1 plus ax plus some stuff with x squared, which we'll just ignore. It's supposed to be x, sorry, not x squared. So 1 plus ax, using the general binomial theorem, it's gonna be 1 plus ax plus some other stuff which involves x squared, which we'll just ignore. Then you got 1 plus bx, then 1 plus cx. And then this guy's expansion is gonna be 1 plus a plus e plus c times x, and then plus some stuff which involves x squared, so we'll just ignore that. So yeah, there it is, the quotient of x term, that will just be a plus e plus c. So a is the answer, and it makes sense, like it should be symmetric. So all of these other answers are like not symmetric, and that's why a is correct as well. 35. If mod of x is less than 2 upon 3, then the fourth term in the expansion of this thing is fourth term in the expansion of this. Wait, what? But then why do you put this thing, this condition? I don't know. Fourth term in this expansion. Okay, so this will be like 1 upon 2 c3, I think. So you got 1 upon 2 c3, and then you have 1 power, well, nothing, because that is not involved in general binomial theorem. So you got 3 upon 2x. Oh, okay, so such that this will actually converge. That's why you had to do this thing. Fine. 3 upon 2x to the power of 3, right? That's the fourth term. Now, what's 1 upon 2 c3? It's going to be 1 upon 2, negative 1 upon 2, and negative 3 upon 2, and then upon 3 factorial. So that's 3 to 2. There you go. Cancels. It's positive. Yes. It's just 1 upon 16, huh? Yes. So 1 upon 16 times this quantity, 27 upon 8, that times x cubed. So it's 27 upon, so it's 848, it's going to be 128 x cubed. Right, not negative, it's going to be positive. Yes. Does that make sense? So the, yeah, it's got to be 3. That's the fourth term. The first term will be just 1. Second term will have 1 upon 2. Third term will be negative. Fourth term will be positive. Right. It should make sense. So 27 upon 128 x power 3, which is a 35th, 36th. The coefficient of x power k in the expansion, where it go, 36, coefficient of x power k in the expansion of 1 plus 1 plus x plus 1 plus x squared and so on. What will that be? Fine. So yeah, of x power k, I mean, you can do it the normal way, right? Of course. So just find out the coefficient of x power k from each of these. So it won't start till you eventually get k, and that is going to be k ck at the first. And then you can have k plus 1 ck and so on till n ck. And yeah, k ck can also be written as k plus 1 ck plus 1. Now this thing will be like k plus 2 ck plus 1, and then that will be combined with the next term and so on. So k plus 2 ck plus 1 plus k plus 2 ck, that will be k plus 3 ck plus 1 and so on. Eventually you just get n plus 1 ck plus 1, and that should do it, which will be a. Yeah. Okay, let's go to 30 37. So if 1 plus x power n is equal to this, then the value of c0 plus 3 c1 plus 5 c2 and so on. Fine, it's actually very much doable. So like just put x squared in there and then multiply by x, I guess, and then differentiate. So you're just gonna differentiate x times of 1 plus x squared to the power of m, and then you will just put x is equal to 1 in there and you will get the thing, right? Exactly. So first you will just have 1 plus x squared power n, which is like 2 power n, I mean, when you put 1 in there. And another thing will be like 2x squared, and then you got n, and 1 plus x squared to the power of n minus 1. This will be 2 power n minus 1 in the end, and this combined with that 2, it will just be 2 power n. Next one is just 1. So yeah, 2 power n into all that stuff. So just 2 power n into n plus 1, huh? So D is the way to go. All right. So let's go to 38. It should work, right? Yes. 38. If 1 plus x power n is equal to this, okay, I know. For n odd, c1 squared plus c2 squared, so on, right? What will that be? So it's just the odd ones and not the even ones. That's weird. Yeah, why are these only the odd ones and not the even ones? Okay, well, think about it. The way we usually used to do this is, I mean, do 1 plus x to power of n and then 1 plus x power n, and yeah, it's like it's like c1 and then you got cn minus 1 and so on, right? Okay, you just want all the odd terms and nothing else, right? If n is, oh, so if n is odd, n minus 1 will be like even, so you got, so 1, in the end it's going to be x power n. You just want the quotient of x power n from this, yes, but we don't want some other stuff, so you don't want oh wait, and what about this series? Like, okay, this series will be okay. We can deal with this series, c1 squared plus c2 squared and so on. So yeah, but what about this series, c1 squared minus c2 squared plus c3 squared and so on? Yeah, think about it. Oh yeah, so this is like c1 cn minus 1 minus, and of course you can also put c0 right there. So okay, this is good and all. I'm gonna put c0 right there as well, so 0 squared, but c0 squared minus c1 squared plus c2 squared and so on. In the end, you'll just have to subtract this and divide by 2. So if we can figure out this and that, we'll be done. How do you figure out this thing? This is easy to figure out. It's going to be 2n c, like this whole thing is just 2n cn, yes. What about this guy? So for that, maybe we should look at this thing, 1 plus x power n, and then you got 1 minus x power n. Why do I say that? So yeah, so like it's got negative 1 power something, so that's why. Right, so as this is decreasing, so let's see. First of all, you just have nc0, so from here you will have x power 0, and then you will have x power n from here, so ncn. From here you will have x power 1 in that other case, so negative nc1 coefficient, I mean negative now, and then you will have nc n minus 1 and so on, right? So in the end, you just put, just gonna put, wait, what are you actually finding? You're just finding the x power n coefficient from this thing. So it's like 1 minus x squared to the power of n. What is the x power n coefficient from this thing? Just wait a second. Oh, sorry. Interruption. Nothing big. Right. So the thing is, n is odd, right? So n is odd, then there's no x power n coefficient over here, right? It's all just even coefficients, so that's gone. That means this whole series is just 0, and now I can just do it, subtract and divide by 2. So yeah, it will just be 2n cn and that upon 2, exactly. Yeah, which is going to be c. See, 39. Is if okay, so they define binomial coefficient, then sum of the series 1 plus nc1 and plus 1 c2 and plus 2 c3 and so on. Hey, I think I've seen this somewhere. This, like, it resembles the whatever. Just do it. Yes. Okay, cool. So what will this be? It's got n, and then you got n plus 1 and whatnot. Eventually you just have n plus r minus 1, and then you got c, this thing. I mean, you could do like n and minus 1, so it's gonna be like 1, so n minus 1 c n minus 1, and then you got plus n c n minus 1 and so on, right? So in the end it's doable. Yeah, keeps on going till you eventually get like n plus r minus 1 c. This minus r would just be n minus 1. Now the thing is, you can write this as ncn, and then this plus that, it just becomes n plus 1 cn, and so on. So it just cascades down. You just get n plus r cn. Yes. So that will be a. 40. I thought it would require something else, but whatever. 40. Okay, 1 plus s. Okay, fine. Then C0 CR, C1 CR plus 1 C. Ah, come on, are you serious? So it's like just C0 CR, C1 CN minus R minus 1, something like that. So, or we could go the other way around. So it's going to be C N, then CR, and then you got C N minus 1 CR plus 1, and so on. It just keeps on going. Eventually it just gets Cn. So C0 and Cn plus R. Yeah, it's n plus R. Cool. So like R plus n. So it's both from 0, R plus 0 to eventually R plus n. So n plus 1 terms in total. And this also goes with n plus 1 terms in total. So it's pairing up perfectly. Now you can see this plus that. This is n plus R. Right. This is also just n plus R. So it's going to be 2n cn plus r. That is what we are looking for, right? This whole series is set. Yeah, so 2n cn plus r, which of these is that? So 2n factorial n minus r factorial. I mean, it's supposed to be n plus r, not like that. A is the way to go. 41. The coefficient of x. What is this? A power 8, b power 4, c power 9, d power okay, 9 in this. Oh god. A, B, C, A, B, D. So you see all three are there except one is not here, right? Oh, you can just take A, B, C, D out. What I was saying. A power 10, B power 10, C power 10, and D power 10 out. And then it's going to be 1 upon A plus 1 upon B, 1 upon C, 1 upon D of 10. Now compare it with this thing. It is like A power 10 upon A squared, and you got B power 10 upon B power 6. So yeah, basically we are looking for 1 upon A power. So this coefficient will be the same thing as the coefficient of 1 upon A power 2, 1 upon B power 6, and 1 upon C power 1, and 1 upon D power 1 as well. In the expansion of this thing. So like this. Yes, exactly. So that will just be the multinomial coefficient. 10 factorial upon 2 factorial, 6 factorial, 1 factorial, 1 factorial, right? That should do it. Yeah. Now these of what is add up to 10, and that should happen. Otherwise, it's just really not correct. Okay, so you got the thing, right? Let's calculate this thing. So in fact, these are like, yeah, okay. Fine. So this is gonna be till 6 factorial is 10 into 9 into 8 into 7. That's it, huh? 6 factorial eats the other up, and upon 2 factorial is 2. So 5, right? It's gonna be 40. Yeah, 40 into what? 63. 63 into 40 is just, what am I doing? 63 into 40, which is like 24. 12 is 252. So like 2520, which is C. So 41st C. 42nd. Come on, get deleted. What? Why am you? Okay, 42nd. Coefficient of x power 5 in the expansion of this thing. X squared minus x minus 2 power 5. Oh, come on. Are you serious? It's going to be really bad. Oof. Fine. Just have to do it now. Oh, we could factorize this thing, right? Yeah, but in the end, you just want to find the actual coefficient. So, fine. No big deal. Let's do it. So you just got x squared power of a and x power, so negative x power p, and the 2 will have the other power. Alright. What you want is 2a plus b to be equal to 5. What can a and b be in that case? So ab can be, you can start off at 0, so 0, 5, and then you can have 1 and 3, then 2 and 1, and that's it. That's all you can have. So you just got 3 cases, figure it out, no problem, right? Just calculation. Okay, and then I'm gonna add the C thing as well so that it's actually doable. So 5 minus this thing just 0. We got 5 minus 4 is just 1, 5 minus 3 is 2. First of all, we'll figure out the coefficient. So C of C and C of that. What are these things? We'll figure out what these are. So 5 factorial upon, well, it's just 5 factorial, really nice, just 1. Okay, this guy's gonna be 5 factorial upon 1 factorial, just go on, 3 factorial. So 5 into 4, that will be 20. This is gonna be 5 factorial upon 2 factorial squares, like 2 factorial, 2 factorial, and 1 factorial is just gone. So 5 into 4 into 3 upon 2, which is 5 into 2, is like 30. Okay, and then we'll figure out the other part. So you will need x squared to the power of 0 and negative x power 5, so it's gonna be negative, right? Negative 1, there we go. And then 2 power nothing, so yeah, no worries. Then you will have 1 3 1, so it's gonna be negative 1 power 3 is gonna be negative as well. But then negative 2 power 1 so it's only positive actually. And what that means is, yeah, just negative 2 power 1, so 2 power 1 is the way to go. This times 2, and over here you just have x squared power 2 whatever, negative 1 power 1, that's negative, and then negative 2 power 2, that's still negative now, so negative 30. And then you got this times of let's write that down below actually, it's negative 30 times, so you just have 2 power 2, so 4, right? This is going to be the thing. So there we go, negative 120 plus 40 minus 1, so that will be negative 80 plus 1, which is negative 81. So D is the way to go, 42D. Let's go to 43. Coefficient of x squared y cubed in the expansion of 1 minus x plus y to the power of 20. How hard, how easy could have made this? Can't believe. So like it's just 20 factorial upon 1. Oh, so like that has 2, that has 3, so it's gonna be combined 5, so 15 factorial. 15 factorial, you got 2 factorial, 3 factorial, whatever. So negative x to the power of 2, that's positive, y power 3. Okay, cool. This works out. So this thing. What is this? Are you like serious? Yeah, I mean, that's how it is, right? It's got to be like this. So um, it's power 20. How can this be? None of these. Yeah, it's not 15 factorial. If it's not that, it's not correct. So D, none of these. 40, 30. Okay, let's go to 44th. Coefficient of x power n in this is non-zero, then n cannot be of the form. Oh, okay. So once again, you just do it like 1 plus x, and then you got 1 plus x times all of that stuff like that. It's only 1 minus 1 plus x cubed. It's about 100. Yes. So this will give us terms of the form like some constant, and you got x power 3k. That's it, right? And then 1 plus x over here. So this will only have like 3k and 3k plus 1 powers in its expansion, right? When you multiply by 1 plus x, that's going to be the thing. So n cannot be of the form 3r plus 2 as where r is an integer. So C is the way to go. Okay, cool. Let's go to 45th. The coefficient of x power 28 in the expansion of 1 plus x cubed minus x power 6 to the power of 30. Alright, x power 28, huh? Oh, this is going to be really bad. Wait. It's all just having x cubed right there. Okay, so whatever term you make, you will only have x cubed and x power 6. So in the end, it's going to be some multiple of 3 in the power. So if it's only 3 multiples of 3 in the exponent, how can you even get 28? You can get 30, yes. You can get 27. You cannot get 28. It's only 0. So there we go. All 45 or 45 of these done. Are there answers for this thing? No. Okay. So this is it. I'll see you guys in the next video. Bye.